Okay, guys, starting on page 90, we filled out the table last time. So let's go ahead and finish that one off. We determined 1 was 3, 2 was 6, 3, 9, 4, 12. B, I was just multiplying by 3. So we always write our coefficient before the variable when I'm writing a multiplicative explanation, algebraic expression. Page 90.
Oh, you say you did it.
On this one, what if the market had 25 bags of apples to sell? How many apples is that in all? 75, because there's 3 in every one of those. So that would be 75 apples. Now a truck arrives. It has some number A of apples. How many bags would be purchased? So in other words, now I'm looking at my chart from the other direction. I say I've got some A number of apples. How would I figure out how many bags I need to use? Dividing by 3. So I would take A and divide it by 3. Or if you wrote it this way, that's also fine. So A divided by 3. Now that truck that came in, we count, it had 600 apples. How many bags would I need in order to bag them all? Jaden? How did you get 200?
We did this one last class.
Okay, someone over here didn't have all this, so. Jaden?
You would divide 600 by 3.
Good job. So I just take my expression, I put 600 in for the apples, and I divide that by 3. That gives me the 200. Everybody see that?
Yep.
So here's our big deal. What was different in D from B? We had to use inverse operations. And that's kind of what I want you guys to think about, because whether it's addition, subtraction, or multiplication, division, whenever I go from one side of the table to the other, I'm just doing the inverse with that same number. Everybody good so far?
Yes.
Okay, go ahead and turn to page 91. Did we do some of this one?
Yeah, we did the chart.
You did the chart? Okay. So I'm going to go ahead and fill in the chart just for the video. So the key here, it was in dollars. So our refund for 1 would have been 5 cents. 2 would have been 10 cents. 3, 15. 4, 20. 10 would have been $5. 50 would have been $25. 100 would have been $50. To find out some number C, I would have taken the 5 cents times C. Again, always putting our coefficient before the variable. You gonna find these pages, Jubei? You should look through your papers from last time. We tore them out last class. So if we let C represent the number of cans, what's the expression? I already did it for you. That's that 5 cents times my variable C. Now let's find out how much money he would make if he returned 222 cans. In other words, I'm going to put that 222 in for the C. So I'm going to take 222 times 500. Remember, when I multiply decimals, all I do is count my decimal places, put it on the top, and then I ignore them. I'm just multiplying the number. So the same as 222 times 5. So 5 times 2 gives me 10. 10 plus 1 is 11. 10 plus 1 is 11. Once I have finished the math, now I go back to my number up here. That's how many decimal places I'm going to put into my answer. So I count from the right side, and I come in 1, 2 spaces. It goes between that second and third one. So how much did he make? That was interesting. He made $11.10. Everybody see it? Sophia?
What is this, the number of the containers? I was thinking that since we had 100 to $50, we just add that.
If you were using...
I thought if you were using the chart.
Oh, I messed up the chart. Silly, Mr. Moore. That would have been 50 cents, not $5. I got ahead of myself. That was 50 cents. That was $2.50, and this one was $5. Sorry about that. But I love your point there. So what Sophia was saying is if I go to my chart, if I had 200s, I'd have 2 of those $5, that's $10. That's 200. 2 of the 10s, that's 2.50 cents is $1. So that would be $11 because $10 plus $1. And 2 of them I already found is 10 cents, so $11.10. So as Sophia just said, I could have just used my chart to figure out all that out. Make sense?
Yeah.
So I apologize for that math there. So now I need to earn $4.50 for returning cans. How many cans does he need to collect and return? Well, if I multiply to go this way, what am I going to do to go the other way? Divide. So I'm going to take my $4.50. I'm going to divide by 5 cents. To divide by a decimal, the first thing I need to do is...
Move it over.
Elena?
No, I was gonna give you the answer. Oh,
Well, Kaden?
carry the decimal.
What do you mean carry?
Carry the decimal. Move the decimal up.
No, we need to move it over first. I got to get rid of it in my divisor. But when I move it there, I also have to move it on the inside. So now I say 5 goes into 45 9 times. I don't have anything left, but I've still got a 0, so it's going to go 0 times. So that means he needs to return 90 cans. Yes?
Why would you divide 500 instead of 5 cents?
500 is 5 cents.
I'm done. Sorry. So never quite.
So it's 500ths of a dollar,
Oh,
which is 5 cents. Does that make sense?
yeah, it does.
Okay. So how are they different? That same term, we're now using inverse operations. Everybody understand how we're building those?
Yes.
Good, because that's a good segue into what we're going to do today. You can actually, actually, we can do this one. Yeah, let's do this one real quick. Guys, this one should be very easy. Fare is $2.50. So if I do one ride, how much is that going to cost me? $2.50. What if I do 2 rides?
$5.
$5. $7.50. $10.
$12.50. $25.
Good. Then 3 times that, so that's going to be $75.
And then R.
So my R, to get to this side, I'm multiplying that by 2.50. Once you get the pattern, once you get the idea on these guys, these aren't super hard. It's just making sure you put them all together correctly and actually do your homework, right, guys?
Oh, yeah.
Not to mention any specific names.
Where are you looking at? Tiger. Oh.
Oh, maybe Tyga, Jubei, Dylan.
What?
Unfortunately, only as far as I've gotten so far. I'm sure I can add more to that.
Who's Dylan? Oh, that.
Okay, R represents the number of rides. What's our expression? We already did that. Guys, pay attention. So 250 times that number of rides. So how much money would 60 rides cost? So what I'm going to do is take my $2.50, multiply by 60. I've got 2 decimal places. Now I just do 250 times 60. I get 2 zeros, 30, 12, 15, $150. So I put that 2 decimal places back in once I get to my answer. That's not a good sign. Our next one, if a commuter spends $175, how many trips did the commuter take? So I'm going to actually just use my table on this one, guys. If I did 275s, it'd get me to 150, right? If I did 2 sets of 30, 75 times 2 gets me to $150, right? So that's 60 rides, plus another 25, 150 plus 25 gets me 175. So I did 2 of those and 1 of those. So 230s is 60 and a 10, 70 rides. Does everybody understand how I use my table for that?
Yes.
The other option would just take 175 and divide it by 250. You'll come to the same answer. How are part B and C different? Are D and C different?
Inverse multiply versus.
There we go. Inverse operations,
I thought multiply versus divide.
which is inverse operations. So if you did multiply versus divide, that's the same thing.
Are we gonna do or add versus?
Sorry?
$3 and 6 cents.
Yes, we do something else now. So we'll skip this page and open up this. Should have been the last one you taught out last class, 96. Yep, page 96. Many of you tore it out last class. Here's the deal. I want to see how you guys struggle on this one a little bit. See who can understand what the patterns look like to fill these numbers in. So I'm going to give you 6 minutes to work together as a table. You guys can finish as many of those problems as you can, okay? So you have 6 minutes. Go ahead. Okay, go ahead and tell me the numbers. Good, Colin. Hold on, guys. Listen. 4. Listen. 8. Okay. That is quiet. 4, 8.
Everyone's screaming at me. I don't want to do it anymore.
Go ahead.
No.
Tell me. It's a lot easier to just read it.
Everyone's screaming at me. Like I love.
Tyler, keep down. Read me.
Peer pressure. Stop touching me.
4, 8.
12.
12.
16. Yeah, what he said.
I'm waiting for you.
I agree. 16.
16.
20. No.
20.
90.
90.
I don't know. I'm not.
Interesting. Okay.
800.
800.
And 14.
40.
Get away from my.
Okay, I hear a lot of people not agreeing with what she did.
No, I'm very not.
Zoe?
Okay. So the 4, and then no 8, the 6.
Okay, so 4, 6.
Yes. 8, 10.
8.
8, 10, 12.
10,
That's
12.
how far I got. Wait, I got it.
Kaden?
4, 6, 8, 10, 12, 102, 402.
102. 402. And then,
4 for the 14.
so the same 14.
Yeah.
Kale?
So everything. So it's 4, 8, 4, 8, 12. Wait, no.
Okay, so let's just take a step back. Let's take a look at our picture, guys. Because the picture was designed to help you, believe it or not, Joaquin. So what we did is we said, okay, I can put a chair on each side of the table. So our first one, we had 4 chairs. Then they have a larger party come in, so they put 2 of the tables together. So now I can still set people around it, right? I can put 1 here, 1 there, put 1 at the end. But I've now lost those 2 seats, didn't I? Because they can't sit there anymore. Yes?
Well, you're trying to put it, but you can't squeeze a person in between tables, so you can't count people at the second table, because it's not flat pancakes here, we're not squeezing in 4 ourselves.
Good. No, we're not. So now what happens when I put 3 of those tables together? I've still got those guys that can sit on each side of the table and the guys that sit at the end. So yes, this is our correct table. That's what you should have had for yours. If you didn't have that, go ahead and copy it down. But let's talk about this next part. We'll go through this to help think about this. Are there any ways to think about this problem? We could have modeled it, yes. Model, or we could have written an expression. An expression would also help us because then we can figure out exactly what we're doing. So if I start getting to the 50, it doesn't make sense to actually keep doing the models. So how many chairs would fit on the long sides of the table? There's our first question. In other words, when I'm saying the long sides, guys, talking about these sides. If I had 50 of the tables all lined up, how many people in total are sitting on those two sides of the table? Now, just on those two sides. 100, because I have 2 on every side, right? So that would mean 100 chairs would fit on the sides. Now, how many fit on the ends of the long table? 2. So how many chairs fit in all? 100 on the long sides plus 2 on the end? 102. Does everybody understand where that number comes from now? Who said no? I heard one no. Maddie? So where that number came from, it's saying I now have 50 of these tables, right? So I can put 50 people on this side, right? I can put 50 people on this side. That gives me 100. But I still have these 2 seats down here at the end, right? So 100 plus those 2 that are sitting at the end for a total of 102 people. You see it? Good. Now that we've got that, excuse me, if I had 200 square tables, how many are going to fit on the 2 sides?
1.
I have 200 long tables, or 200 square tables, all lined up. How many are going to fit on the top side? 200. How many are going to fit on the bottom side?
200.
So how many is that? 200 on each side. 400 on the sides. Does that make sense? What about on the ends? 2. 1 on each side, right? So how many is that?
2.
So does this help you guys see what we've been doing every time?
Yes.
What am I actually multiplying? Not 4 sides, because the 2 ends keep moving, right?
Yeah.
How many sides do I multiply every time?
2.
2. So I'm multiplying 2 times the number of tables, because I've got a person that could sit on each side of that table. But then what else am I doing?
You're adding 2 from the ends.
Adding the 2 from the ends. So what does that last one in our table look like? It's not 4t. It's 2 times the number of tables plus the 2 end chairs. Because I'm putting 1 person on each side of every table and then 1 on the end as I keep moving it out. Does that make sense, everybody? Okay, let's go to the next page. Here's another one. Now that you got it, hopefully are starting to get that concept, I'm going to give you 3 minutes to work through this one as a table. We got to move.
Wait.
Okay, our first one. Here is the big deal, guys. They're charging me $4 for each pizza. Makes sense. I charge $2 to deliver regardless of how many pizzas are ordered, right? Because if I order 2 pizzas, does the pizza guy bring me a pizza, go back to the shop and bring another one? No. So does he have to charge me for 2 trips? No, he's only charging me for 1 trip regardless of how many he brings. Does that make sense to everybody? Because he's not making multiple trips. There's no need to charge for every single pizza for the delivery piece. But does it cost the pizza shop owner to hire the guy to bring that pizza to me? Yes. So he has to recoup his cost. So he charges me for that one-time trip to get to my house and deliver that pizza to me. So that being said, on the first pizza that is delivered,
$7.
I have to pay $4 for the pizza, and I pay $2 for it to be delivered. So how much is that?
$6.
$6. If I do a second pizza,
10. Whoa.
why do you say 10, Sophia?
It's 4.
Why would you say 10? The first one was 6. Wasn't the next one be 12?
No, because it says for every, every time, so it's not going back and forth.
So how much am I adding for that second pizza?
$4.
$4. So it's $10. Sophia, just because I ask you if you're right, don't immediately clam up and think you're wrong. Because, Caden, did I have to pay another $2 for that second pizza to be delivered? No. All I had to pay was the $4 for the next pizza. So what about my third pizza? Now what am I at, Gabby? Okay, go ahead, ask. Swami? $14. Because again, now I just added another pizza, another $4. Then we go to 18, because it's another $4 for the next pizza. So at 10 pizzas, now what am I up to?
40.
Good. 40 just for the pizzas, plus my delivery cost of $2. What about for 50 pizzas? 50, yeah. No. $4 for each of the 50, that's 200, plus my $2. So, was anybody able to figure out my expression? Joaquin, you got it? Joaquin? You got the expression? What is it? Do I ever put the variable before the number? Coefficient always comes first, right? So I like what you said, just not how you said it. It's 4p, and then what? Is that it? So 4 times 2 is 10. 4 times 4 is 18. So guys, we're missing something. What are we missing?
Oh, is it, I don't know, is it 4p plus 2?
Is it? Let's try that. What if I did? Hey guys, this isn't working. You guys are going to have to move back to where you were, because since you've been here, this table is way too loud. Let's check it. So if I have 1, 4 times 4 is 4, plus 2 is 6. 2 times 4 is 8, plus 2 is 10. Does that look like it's working? Yeah. Good job.
Yes.
So what mathematical operations did we have to do to find the total cost? We needed to multiply and add. So we had to do both of those things. Let's say our principal wanted to buy pizza for everyone in our class. How much would that cost? Anybody count up how many we have in here? What? 51? How many people are in here? 21. So we have 21 people. So we can now use our expression 4p plus 2. But now we know that we need 21 pizzas because everyone gets their own. So I'm going to take that 21 times 4 gives me 84. Add in our 2 for our delivery cost. And we get a grand total of $86 for everybody to get their own pizza.
Wait, so the person can either slice or...
Probably, I mean, at $4 is probably like a double slice.
It's a double slice. It's a double slice. You get to slice it.
Okay, now our booster cup. Guys, come on. We still got a whole other section to get through. The booster club has $400. How many pizzas could they buy for everybody? Gabby? Huh? How many people or how many pizzas could they buy? Sophia? What's our expression say? If I did 4 times 200, that's already 800. That's double what I've got. And I haven't even added the delivery charge yet. Okay?
They could buy 100 pizzas? No.
Could they? Let's try it. If I had 100, and then I'm charging $4 for all of them. Add in the $2 delivery charge. 400 plus our 2 is 402. I'm over budget.
They can't. They have to.
Can't do 100.
It's 98.
I have to take 2 pizzas away?
You only take 98 pizzas. No, you take away 1 pizza.
Take away 1, because I'm only $2 over, aren't I?
Yeah.
How much is a pizza?
$4.
$4. If I go down by $4, wouldn't I be able to buy that?
Yeah.
So it's 99 pizzas. But guys, these kinds of questions, a guess like that is really easy to check because it's doing double zeros. And it gives you a very good way to get to your actual answer. Okay, our next one. We're just going to fill this one out. All we're going to do is change our prices. We raised the price to $5. The delivery price raised to $3. But it's still just that one time. The guy comes to my house. Doesn't matter if he's carrying 1 pizza or 5 pizzas. It's just one trip, right?
Yeah.
So it's 1 delivery charge. So if I do 1 pizza, I have that $5 for the pizza and the $3 for the delivery charge. It's going to cost me $8. Now I'm going to buy an extra pizza, but he's still doing the same delivery, so no extra charge there. So I'm just adding $5 to that. It's going to be 13. Our next one, we just add 5, just add 5, just add 5. So what's the difference? The difference is only what am I charging per pizza? It's now $5, and it's now just that one-time $3 delivery charge. Make sense?
Yes.
Okay, let's go to our first one that we tore out for today. Go to page 96. Oh, we just finished that.
Yeah, 199. The green one is yeah, 101.
Actually, go back, guys. We did this one, right? Yeah, we did that. Guess what, guys? You're actually done.